Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be looking at polarity, which is, kind of what makes things polar or non-polar. So the first thing that you need to realize, right, is that polarity is like a game of tug of war. So there are winners and there are losers. The winners get to share those electrons and have those electrons way more often, whereas the losers don't get to keep and share those electrons as often than the ones that are better at that game of tug of war. So, how exactly does the game of tug of war work? It works off of the principle of electronegativity. So, the elements that are better at attracting electrons to themselves and pulling electrons to themselves are the more electronegative elements. And so, thus, they're the ones that have that partial negative charge. And so, if you have elements, let's just make it simple. You have two elements, they're in a game of tug of war. If that pull is uneven, meaning you have something that's more electronegative, you have something that's less electronegative. As they pull on those electrons, that means that that is going to be an uneven sharing of electrons. And so that molecule will therefore be polar. So again, we defined what polarity was before, but the key now is that it is because of the unevenness of those electrons being shared that polarity is even a thing. That's what makes things polar. Now, if the pull, on the other hand, is even, then that means that the molecule is nonpolar. If the electronegativity of both is the same, or if the pull is equal, it's like playing a game of tug of war and you're equally matched, then there's not really going to be a charge difference at all, and so your molecule is nonpolar. How do we figure this out? Well, you have to be able to draw the Lewis dot structures, that's one thing, and you have to be able to understand how to find that geometry using your VSEPR chart. So this is your VSEPR chart. Remember, this only covers things that follow the octet rule, and this only covers, technically, I guess, covers things that don't follow the octet rule, but it only covers things where your outer atoms are exactly the same thing. If they're two different things, that's not really going to work. But if they're the same, it'll work. So I want you to color code this. So you have these three are going to be blue, these three are going to be red. What do they represent? The blue ones, those are non-polar things. So these are the three non-polar geometries that you need to be aware of. These three are the polar geometries that you need to be aware of. Notice the polar things all have lone pairs of electrons on their central atom. That is a key. So that covers almost everything. But remember, we also talked about compounds that only have two elements or, only two atoms in them. Then that game of tug of war becomes extremely important. So what you need to think about is these two different things, right? I have N2, I have H4, or HF, not H4, that makes no sense. One of these is going to be polar and one of them is going to be nonpolar. The question is which one's polar, which one's nonpolar, right? You might look at it and say, hey, they both have the same shape. They have to be the same thing, right? They both are linear, they're flat. There's only two elements next to each other. Well, let's draw it, right? So draw the structure for N2 and draw the structure for HF, and then tell me which one do you think is polar and which one do you think is nonpolar and why. All right, time's up. That is what it should look like. So if you drew anything other than this, go back to your Lewis dot structure rules, dude. All right, what about this? HF. So again, duet, octet, everybody's happy. Which one's polar, which one's nonpolar? Think about that game of tug of war. This is nonpolar, this is polar. Why? Even pull of electrons. This nitrogen is pulling, this nitrogen is pulling, but they're evenly matched. They have the same electronegativity, so that means that there is no polarity. This is not true of this. Fluorine is extremely electronegative. Hydrogen, not very electronegative. So when you put them together, all the electrons are going to want to go around the fluorine and not spend a lot of time around the hydrogen, meaning that there's an unevenness to that game of tug of war. All right, let's practice. So draw the Lewis dot structures for these, figure out what their geometry is, and then use that information to determine whether they're polar or nonpolar. All right, first one, NH3. Now, what geometry does it have? And do you think it's polar or nonpolar? It's a trigonal pyramid, and so that is an example of a polar geometry. H2S, try to draw it. I drew it totally flat, which remember, that's fine. But if we were looking at this, which one do we think it would be? Notice I have two lone pairs of electrons on my central atom, It would be right here. It would be bent. Again, just because I drew it flat doesn't mean that I can't, use my geometry chart to figure out what's going on. So I have two lone pairs of electrons, and I have two atoms, just like this. I have two outer atoms, two lone pairs of electrons. If it's bent, that means it's polar. Next up, CH4. Try drawing that. Again, I'm going to draw it totally flat, which is okay. Which geometry best fits it? Tetrahedral. If it's tetrahedral, that means it is nonpolar. Notice all the hydrogens are pulling on the electrons evenly. So it's like a game of tug of war where everybody's exactly the same, and you're playing, let's say a game of tug of war with 4 people. So it's not moving. It's just staying exactly in the center. SO3, that one's kind of hard. That's what SO3 should look like. And so again, take a look at this. Which one best fits? It would be this one. Yes, even if there's a double bond, it doesn't matter. These can be double or triple bonds. Doesn't matter at all. That means it is nonpolar because it is a trigonal planar shape. CO2, again, that one, I have 2 outer atoms and that's it. So I have 2 outer atoms, 180-degree bond angle. That means that it's linear, and that would be nonpolar. Last but not least, HCl. That's what HCl would look like. I have a duet, I have an octet. It's not on this list. I only have 2 atoms. So do we think that this is an even or uneven pool of electrons? Answer: it is an uneven pool of electrons. Chlorine is going to be way better because it's way more electronegative, and hydrogen is going to be way worse at pulling on those electrons, so it would be polar. All right. If you have any questions, let me know. But that was it.